so you're helping me.
With that, our next talk will be from Martin, talking about fast prototyping for computer architecture research with Chisel.
Oh, gosh. That's so small here. Okay. Thank you for the introduction. Yes, I'm Martin Schoeberl. I'm coming from the Technical University of Denmark. So one of the non-US here. Chisel. I mean, Chisel is a relatively new language, so everyone has kind of a personal connection, maybe. So I started to use Chisel in 2012 when I was here at a research visit at UC Berkeley by just rewriting a process as an exercise. Since then, all my hardware has been in Chisel, like processors, network-on-chip stuff, distributed on-chip memories. And just to give you my experience with Chisel, start with a very small design and run through it as I did it. It's a tiny processor called Lipsi. So it's intended as an exercise, small processor, simple instruction set. So the target was kind of like building the smallest processor of the world, probably the smallest processor in the world. If you know some ads from Carlsberg, this sounds maybe familiar. Can be used for small stuff like a software-based state machine, or in teaching, introduction to computer systems. You can see the full instruction set in one slide. It will be easy to start with. And the design I did actually on an island called Lipsi, so that's the reason why it's called. So where's Lipsi? Lipsi is one of the Greek islands, and there's around is a Patmos and there's a Leros. And if you Google Leros processor, Patmos processor, actually there are 3 processors around. But let's stick to Lipsi. So the design of Lipsi was done on paper. This is actually the main design sheet. I have actually the features already there. I want to like less than 200 logic cells in FPGA, and the full data path is written out. So a very simple design. You see some code snippets, Scala Chisel code, as you're used to. And then when you start processor design, you start with ALU maybe, some Chisel test benches, your first instructions, and then you write manually building your assembly code into your Scala testers, and then it doesn't scale, so you need an assembler. So usually when you use VHDL or Verilog, how do you write your assembler? You write it in Java, Python, whatever. I've done this several times and spilling out VHDL code. But not so in Chisel, because Chisel is Scala. Scala, you have the full power there. You can write an assembler in less than 30 lines of code for a simple architecture. And then you're generating your hardware, read-only memory at hardware generation time. And it's all in one program. So this is a snapshot of how to write an assembler in Scala. Not a big deal. Then, when you write hardware, you have to do some simulation, you have to do some testing. Yes, you can start with looking at waveforms, especially in pipeline designs. You might look at waveforms at some point. But actually, Chisel and Scala pushes more towards unit testing. So let's do simple testers in Chisel. Let's have an agreement that all test cases should end with a 0 in the accumulator. And then, yes, running those small test programs. Maybe if you don't mind. So let's say I have this simple assembler test program, and it exits, it should result with 0, so we're running this with make test. Or maybe it's not so excited. You should see at the beginning, so it runs, it reads in the assembler program, it assembles everything, then builds a C program, and at the end running the test, and everything is fine. And, okay, maybe jump away. However, this writing assembly program, self-testing, is getting boring. I don't want to write so many assembler tests. What about doing some co-simulation? So it's also common practice in processor design. You're building a hardware and you're building a software version of the processor, and then you're running those tests against each other, testing register files or whatever. But now I'm in the Scala world, so let's write the simulator of the processor in Scala, and then having a software simulation of Lipsi, and again, it's the same language. So I can run, of course, my test assembler programs on the simulator as well, but now I can do co-simulation. So I'm running in lockstep the Chisel code and the Scala code. I don't think we should do the demo again, but I could show you some, maybe not. So actually, so this is a simulator. This is plain Scala code, not a big deal, right? This actually is a 200 lines of Chisel code to build this processor. And then if you run this co-simulation, you just run both steps, and then you're comparing some register value. For example, the accumulator in this accumulator machine. So I spare you running. You can trust me, it runs. It's maybe a little bit boring. So, okay, you've seen this design example, building a hardware in Chisel, building an assembler in Scala, building a software simulation in Scala, writing co-simulation, writing a little bit of test benches. So what is your guess how much time this takes? Maybe some random guesses. You've seen the code. It's a bit of small design, yes? Sorry? What? One afternoon. Nah, that was very ambitious. No, it took me 14 hours, the whole thing. Writing the hardware, writing assembler, having a blinking LED running in FPGA, simulation in Scala, having these two testers. I think that is quite good. I mean, I'm not a very fast coder, but the design itself is not part of this 14 hours. This has been done on a vacation on Lipsi. You've seen this design on one sheet of paper. Good. Some more examples is more laundry list. So this T-CREST project is a multi-core system with processors, network on chip, and stuff. And actually, this is where I started with Chisel. I had a VHDL version of a processor done by a PhD student, not very smart written, but whatever. It was roughly 3,000 lines of code, and I said, okay, it's time for redesign. You have to rewrite it anyway. And then, actually, to excuse it that I do the rewrite, I say, okay, let's do Swiss language. And this was my exercise to learn Chisel, to rewrite this processor. And then you have several PhD, master, and bachelor projects, and most of them found Chisel actually relatively easy, most. What else did we? I did a simple network on chip, also in Chisel. I will come to this back again. We did some shared memory stuff. We did some synchronization support for multi-cores. We had even an asynchronous version of the synchronization support. Asynchronous in the hardware design. Synchronization is about the software stuff, about locks. This was actually very low code representing an asynchronous design for an FPGA running. Yes, threshold memory with synchronization support and distributed shared memory. Network on chip, another design example I want to show you. The original network on chip was written by a PhD student in VHDL, and then another PhD student wrote a generator in Python to spill out VHDL code, the usual thing. And I did a similar thing. I couldn't convince those people at that time to switch to Chisel as well. My fault, sorry. And I did actually a knock in Chisel. I'll show you quickly. Okay, this is, all right. Anyway, you see this is build out code for just a 2x2 core. And it's 200 lines of code, and the generator code in Python is 15 lines of code. So if you look at Chisel, the lower 12 lines of code is actually connecting a NOC routers. It took me maybe an afternoon to write this code. It might take me another hour back to read it back, but at least I have on one screen, so I can get back the functionality. Good. Oops, sorry. Oh, that's not that one. Good. Time to move on. Oops, no. This one. Teaching, I'm associate professor at DTU, so I'm teaching Chisel in advanced computer architecture. About 3 hours, I give an introduction, and actually since 2016 all projects have been in Chisel. I don't enforce Chisel, I just offer it to students. And I did some tutorials in Europe as well. And students actually pick Chisel up relatively fast. And we have a lot of software engineering students. They find it way easier because it feels so familiar with like Java, whatever, Scala, to get into hardware designing. But the issue of writing a program instead of describing hardware, this is the same, be it Verilog, VHDL, or Chisel. This is a different issue. Oops. Good. In summary, I think the combination of Chisel and Scala is a very powerful combination. Hardware description can be very concise. It's a small process. Of course, the small is just 200 lines of code. I've showed you 12 lines of code to connect the NOC generic. And having Scala at your hand, you can do an assembler, you can do a simulator, and software simulator, and run this in co-simulation. And I've shown you, not in an afternoon, but I managed to do this in 14 hours. And more to be explored by myself.
Thank you. As always, if you have questions, come up to the mic. I'll start us off with one. You commented on courses with people being allowed to use Chisel. Do you think the transition to using Chisel is easier for people with software backgrounds who are learning more about hardware, or for people who have hardware backgrounds that may be learning like software engineering techniques?
I mean, early in the morning, we've heard a Google talk about people learning Chisel, and then the next step in learning Scala. And hardware engineers coming from a Verilog background, I think they have a harder time to get into all this Scala, object-oriented functional world. I think students who have a good knowledge in Java, I have had only one student who knows Scala before, they actually take it easy, I think. It's more, it feels more familiar to them, having an EDA like Eclipse or whatever.
So you've said you've been teaching Chisel for a little while now. Have you built up some amount of documentation or sort of examples that you have found to be particularly effective in convincing people or teaching them Chisel?
So I have a small collection of examples, way too small. I've started to write the book Digital Design in Chisel, which is in version 0.01. It's just started. But I have some slides. I put some slides together, which I did a tutorial at some places and that I'm using. I tried to work more, contribute more on the documentation side here. We really need some teaching material. I completely agree with you.
So originally, you mentioned you started using Chisel in 2012, and since now we have Chisel 3, are most of your designs in Chisel 3 or still in Chisel 2?
What was the last question?
Have you migrated your designs to Chisel 3?
Not all of them. I started to new designs in Chisel 3, but the big design, my T-CREST project, multi-core Patmos processor, blah, 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 is still Chisel 2. Maybe during my stay here, I might manage to move to Chisel 3. Thanks.
All right, let's thank the speaker.